I know. Now you need to work together. If you see, yeah, now you work together. Right? Otherwise, you lose this grade. Yeah, do together. 3 more days. Okay. Yeah. Okay. Thank you for your leadership. Okay, you may start.
Good evening, ladies and gentlemen. My name is Nitaiwo, and I represent Group 4. Basically, concerning our project, what we talked about, or the problem we're trying to solve, is the issue of house pricing in Vancouver. Just as you know, housing is basically one of the basic units of life, which is clothing, food, and shelter. And Vancouver is a place that is quite expensive compared to every other provinces, or BC generally is quite expensive compared to other places in BC. And and if you look at the statement problems here, Vancouver has the highest cost in real estate, and people find it very difficult to actually rent or buy properties in Vancouver. But why is this?
Presentation more. Presentation. You know how to put it? Presentation more. Yeah. Too small, yeah? Thank you. Great. That's
Do you want to next level to see if that's
have this one. Yeah. Presentation mode, yeah. Not working? Yeah. Okay, that should work. Okay, should work, yeah. It's not gonna. Yeah. All right. Professional.
So basically, we all know that Vancouver is cost of living in Vancouver is actually very, very high. And why is this high? Well, for various reasons. Compared to every other provinces in Vancouver, there are things such as weather, jobs, job opportunities, and all, and which makes people actually move down here because it is quite favorable. Now, we showed various problem statements here. Vancouver housing market has suffered many fluctuations with tendencies to keep rising. And like I said before, population, the influx of immigrants and other people from different provinces has actually contributed to this, which has actually shown that prices in terms of sales and rentals has actually increased over the years. Now, basically, what are the tools that we have actually used to solve this problem? Well, it's quite simple. In order for you to actually understand the purpose of what we are trying to do here today, I can only show you through Tableau visualization, which actually shows the visualization of data. And we actually use clustering Python and also Excel. Now, clustering here it has to do with the fact that we are using only one entity, which is human beings and housing, which in terms of population and in terms of influx of people. And that is why we're using these two data. Next one, please. Our data set description, it says that housing data has been collected through Cargo. Now, basically, on Cargo website, the information I was able to extract, or we were able to extract as a team, shows that the Cargo file had over 5,000 informations, and we needed just 1,000, which is 5,000 rows and 600 columns. And in terms of the pricing, we could see that there are different locations in Vancouver, BC, which is such as Abbotsford, North Vancouver, Richmond, Burnaby, Surrey, and all. And property is actually different in terms of types of accommodation. It could be a house, it could be an apartment, it could be shared rooms, and all. Now, before we actually talk about our visualization strategy, I would like to explain that not all of our data that we've been able to extract were properly cleaned, and were cleaned, and this is because we didn't have to change the NAN. When you look at the data we actually retrieved, which is in our other file we sent to your email, in our rows and columns, all the rows and columns were filled with every single variable, and we're not missing any variable there. Hence, we didn't need to actually clean any of these data. Now, these are various informations of different housing and different qualities or functionalities of different properties in Vancouver, BC, that we can see. Black marble, which are the fittings in the house, solar, glass doors, electricity, and gardens. Now, the reason why you have all these data is because people have various preferences in terms of properties, in terms of the kind of homes they want to live, how many people live in these areas, what kind of jobs do they do, what's the cost. And these are the informations you've been able to get on it in terms of the utility of electricity, in terms of the glass doors and all, and you look at the pricing, the average price over the years, and how many people have been able to go for properties that actually consume more utilities in the house. And if you look at this, in terms of the amount per year, you'll see that it has over 42,283. In terms of black marble, well, I wouldn't like to go into details in terms of types of marble that are in the house, but we both understand what it means to actually have all these facilities in the kitchen. And this has been a basic visualization of every single data of most of the properties in all the locations I've actually mentioned earlier. Can you move to the next slide? No. Push. No, go back. Sorry, please. Okay, now can you go back to the way it was? Sorry. Can you go to slide 11, please? I think 11 also has information. Just keep going. Okay. No, I think no, not this one. Okay, you can do this one. It's fine. Just go to this one. Yeah, this one. Okay, so basically in the visualization method, you will find out that I was actually trying to explain better with our visualization code, but this slide here will also be able to actually tell us what we're trying to do. Now, in the information I shared earlier, you will notice that the 1, 2, and 3 bedrooms here, in terms of the price list and their different locations. Now, these are the pricing that actually depicts and explains to every single person here how much each property actually costs in these areas. Now, what are we trying to do here? We're trying to solve the housing problems, which actually shows that 7.9% has been the amount that most people have been able to actually spend on rentals and how much they've been able to spend on sales. And this is because of the mortgage facilities and pricing. So, how do we solve this problem? Is to make housing much more available to people. Thank you.
What's your name?
Ikenna.
Thank you.
So we use the decision tree system as one of the classifiers, and we use N as the number of target classes, and we don't have much target classes and stuff. And we use the random forest classifier, and it has an accuracy of 88.5%, and it has the highest accuracy of all the others. So we concluded that that was the most effective. Then for the K, this is our elbow, this is for the games.
So which tools are you using to generate this one? This elbow? Python?
Yeah.
Good. So what's your K?
We use
what's your K? Class rate.
Then so we use the principal component analysis so that we filter the to make the diagram more interpretable so that we eliminate other factors. So and it minimizes information loss. Then this is the visualization. This is the clustering for the visualization for the cluster, showing different clusters. And this is the plot of the PCA.
So K equal 4, right? Yeah.
Yes.
Okay. How to interpret it? What does it mean? By price or by house type or by
price?
By price? Yeah. Okay.
By price and by both ways it's a scattered way, like in different type of different patterns, houses and different pricing. So we have like scattered those data.
So which color is highest price?
Blue one. Oh, sorry, the three.
The blue one? Yeah.
Red one. Yes, the red
Okay.
one.
Where locate? Which district locate?
Slide.
Okay, good.
Yes, we have like the scattered one over here, like how much differences like the clustering has with the variations among the pricing. Some of them have like very much variation among the pricing. Like the black marble one has like more price, some housing that has like a lower price, depending on the zone of the city, in the Vancouver city. some of the apartments, those are like for one suite apartment, it's like a very high price. And some are the most affordable ones, but those are like in house type with only electricity support, but without any like heater support or any other facilities. But yet the prices are high. So we have just distinguished some of the characteristics of the housing or the household, you may say, and then we have like clustered them here like, by the keywords.
Okay, so what do you classify?
I'm in camp and I lost my voice, don't know if you can hear. So this is the outcome of our research, and we got most of the data from cargo. So looking at this table, we divided our data analysis into the cities and the number of bedrooms, with the maximum being 3 bedrooms. And from this table, you can see that downtown has the most expensive 1-bedroom apartments. And if you look at the 2-bedroom apartments, Surrey and Langley has the least expensive 2-bedroom apartments, even less expensive than the 1-bedroom apartments in downtown. We also conducted a research on the renters' income, renters' income to rent ratio, and we discovered that most Vancouver renters spend close to 38% of their income on rents. We also discovered that there was a region-wide increase on the monthly rent from October to November, and rent increased by 61%. And from our prediction, you can tell that this is going to go on for some time due to the increase in interest rates due to inflation.
This is Hasib. So this is the outcome of renter demographics. So there is a more diverse demography of renters these days. Like that is, there is a recent jump in renters, age 35 and above. However, the younger under 25 demographic is also represented. In conclusion, the majority of Vancouver tenants are aged 25 to 34. We also showed the average cost of unfurnished versus furnished apartments. The unfurnished 1-bedroom condominiums are roughly $96 cheaper than the furnished units in the same month. We also did the breakdown analysis by Vancouver neighborhoods. We break down the neighborhoods, downtown, Kitsilano.
Since you only have 3 minutes left, do you have you done class 5?
Yeah.
Class 5 method?
Yes.
Okay, show us class 5. Otherwise I have to cut it off because we don't have time. Good, yeah, thank you. I'm going to read your final report. So, can you present?
Yes.
Yeah, please.
So as you see the finding.
So what's your name?
My name is Nadia.
Nadia, okay.
Yes. Nadia.
Nadia, okay, got it. Thank
Got
you.
it? Okay, so as you know, so this is the finding of our report, like a maturity report. As you can see, people here like spending 40%, around 40% of their earning in rent, for their rent, living in Vancouver. And Vancouver being the warmest city in Canada, so people, it attracts most of the international students and international workers as well, and they want to live here in between this city. But being with the increasing demand, there is no supply for places for this increasing amount of population here. So what they are doing, they are living outside the city, and it is like killing their time, and sometimes it becomes very difficult for them to come here. So what we recommend, like
Only 1 minute left.
I know. Okay, so from government point of view, what we recommend is that they can use the spare lands that sometimes those are reserved for golf places. So they can use those government lands to build some non-marketing housing plans for these upcoming international students or whoever wants to facilitate from here. Or what they can do, one more thing, like the housing plans going on, like only the house ones, they can offer them that we want to build an apartment here, maybe you can take 2 of the flats from there, and
I have to stop you because time is up. So what's your classifier you're using? Any classifier?
for decision tree.
Decision tree, okay. Show me decision tree. Anything? Decision tree, okay. So this is decision tree.
This is decision tree.
Yeah, okay.
And the K-means.
K-mean, I know that. Yeah. What's else? You only have one classifier? Decision tree. Did you use regression?
Yeah, but
Not sure there.
it's not yet.
Okay, that's fine. You report, yeah? Okay. Okay, that's good enough. Good enough. Okay, let's give a hand for this team. All right. Yeah. Time short. Very interesting problem to solve, yeah? The housing. You know, housing price. Yeah? And in particularly in this Vancouver, it's crazy, yeah? So the people ask what's the impact of the pricing? Of course, location, yeah? And also the characteristic of the house, right? Yeah? Your decoration too, right? The structure, yeah? So this is, you can use the mixture, right? You must answer the 5 questions, right? You need the data, method. What do you find? Yeah, based on that. Yeah, I know, but sorry, but it's very time. You can do it. Yeah?
I want to grade ourselves too.
Yeah, that's good. Good job. Good job. Our review report.
I want to grade ourselves.
Yeah.
I can do it myself.
Yeah, you did very well. You did very well. Thank you. Okay, give a team for evaluation. Yeah. Give a team for evaluation. You guys did a good job, right? So our review report. Make sure you find that, right? Master from each of the method, right? How to solve the problem. Yeah? We are not economicals, yeah? This is not economic. This can be one method. Economical, right? Housing economical. Right? We focus on that. Yeah. Okay? Good. Let's welcome team 5, right?
Yes,
yeah. Team 5. Welcome, team 5. Good. Go ahead.
Thank you. Hello everyone, we're Team 5 and I'm Sachin and we'll be talking about US flight delay analysis and predictive model. Go ahead. So, the airline industry is a multi-billion-dollar industry.
Yes.
And one of the differentiators that builds their brands is how many delays, cancellations and diversions those airlines have. Therefore, the business problem that we're trying to solve for businesses is how do these airlines stand amongst their competitors and which area do they need to improve. And for customers, which airline is the best and which season has the longest delays and cancellations. Next one. So we use Kaggle for our data set. We found the flight delay patterns in the US between Jan 2017 and July 2022. Now because of this, the pandemic years were included and that skewed our data a little bit. So our predictive model was only able to predict weather because that was the only thing that wasn't skewed because of the pandemic. Go ahead. We can skip this part.
How many rows, how many columns?
So we had around 200,000, I think 219,000, this is off the top of my head. 290,000 rows, something like that. And columns we had what, like 10 or so, something like that.
10 columns? 12 columns, okay. Yeah, always, right? Always focus this data. Okay, good. Have a look.
Yeah, this is Muhammad Laif, and I'm going to speak about approach for that.
What's your name, please?
Sachin.
Sachin, okay. What's your name?
Muhammad.
Okay, Muhammad. Okay, thank you.
The initial approach which we have done with the visualization using Tableau, and the data sets which we have used is the US delay data sets. The source for which we have used from Kaggle.com. The data cleaning is done as per the procedure, removing incorrect data and corrupt data and duplications. The main objective of Tableau visualization is analysis and prediction of flights that get delayed using visualization procedure. The visualization for the years 2017 to 21 is employed here. Next, please. Significant reasons behind the delay are mainly 5 types. Delay due to the another flight delay, that is the impact of another carrier flights. Delay due to the national aviation system, example the radars or air traffic controls or something like that. Carriers related delay, example technical glitches or crew shortage. Delay due to delay due to the weather conditions. Example, the unpredictable or uncertain climatic conditions. Delay because of security reasons. Example, the threat or hawk's call received to the security authorities. The consequences of flight delay is airline operation and scheduling are impacted, resulting in increased block times and on routes, block times on routes and dearer or expensive air tickets. After visualization, the first after analyzing the visualization, we observed that the cancelled, delayed and diverted flight status is maximum during the period of 2000 during the pandemic strike period. However, in pre and post pandemic years, that is 2017 and 19, the flight delay status is marginally affected. The next, please.
Okay. I'll take over. So if you look at this beautiful graph, we see that the bar graphs are the total number of delays, and the color represents how much of that delay is represented by one of these columns. So basically what we see is all these logistical delays, like delays due to other late flights, delays due to heavy air traffic, which is the national aviation system, or delays due to there being no crew, was the major affecting factor for delays in airlines. Weather and security delays did not affect as much. Next slide. Now this is a similar chart. This measures the number of minutes of delays. But another thing I'd like you guys to notice is in 2020 the number of delays is quite less, which is an interesting thing. Now why do you think that would be? COVID-19? No, the delays are low. The reason why that is because of course the flight weren't just delayed, they were completely cancelled. So that's why the delays are very low in 2020 because they were just cancelled. That's a different factor. Next slide. Right. So Mohammed touched upon this and I'll elaborate further. So pre-pandemic and post-pandemic we have two conclusions. Post-pandemic we see in the initial months the number of cancellations were increased. But after that, cancellations went down, and instead of cancellations, airlines resorted to delays. So delays went up now, and delays and diversions went up. And pre-pandemic, we also see a pattern. It's quite hard to see, but we see it in January period, which is the holiday season. There's a spike in delays because there's a lot of people traveling, and the same happened during the summer season when there's holiday season. People are going.
Okay, very good work. Okay, let's go to Kemi. Have we done Kemi?
Yeah. Yes.
Okay. Okay, 2%. Yeah. So what's the name, please?
My name is Narendra.
Okay.
Okay, since we are handling a very huge data which has more than thousands of columns, and which is very difficult to figure out to label the reason, specific reason of the delay, we'll have to find out another method like unlabeled or unsupervised method, which is called the K-means. This is basically based on the technique that find out the similarity between the reasons, like property similarity, the reason like delay because of the weather, because of the technical issues, because of the security issues. So we have first initially clean the data. We pick one airline and we try to figure out one airline and a specific period of time, and we plot a scatter plot for that airline's data. Then we notice that we can be able to figure out number of clusters which are making a close relation with each other. So this is the random, we are figuring out the clusters, and then we try to find out the center of the distance. This is a centroid which is having a minimum distance on the center of the each point. So based on this technique, we will keep on minimizing the distance and the center size, and then we figure out the exact center where we can be able to make a number of clusters. And this clusters technique will have the one thing we can say the quality that they are having a unique property, like something having a.
So what tool are you using? What tool?
We are using the elbow method. She will be here to do it.
Okay, good.
Myself a bit. So we are using elbow method just to find which cluster is optimal for the method we are using for the reasons. It is basically a graph between the WCSS values and the number of clusters. The formula is given here. This is just for the 3 distance cluster, but we can use it for the more also. The point where the elbow starts to be horizontal, it is the optimal point for the number of clusters to be according to our data set or for the reasons. So what do we find from
So
this?
which tools are you using to generate that graph?
Excel.
Excel stack. Okay, thank you. That's good. Thank you.
So what did we find from this K-means and elbow method is that the delay is not due to the basically due to the bad weather or the number of flights. It's basically due to the number of traffic and the flights in that area, or the delay of another flight using the same aircraft.
Hi, my name is Amreen and I'm going to explain linear regression. Here in this basic chart, I'm just showing how there are multiple factors affecting the delays. The various factors are for the arrival delays are the weathers, the carriers, the NAS delays and the late aircraft delays. Now what does NAS delay means? The National Aviation System, where they are controlling the air trafficking. Now when they do this, when there is a lot of air traffic, during holiday seasons or during when there is high demand for flights, right? So here I have used this scattered plot to show each and every delay here how reliable is this linear regression. Now the main thing which shows here is our R-square. Now if you see the number of flights which arrived at the airport is this means if they arrive 15 minutes before or after the scheduled timing, that means they have arrived on time, and this data is 64% reliable. And the main thing is our intercept, where this derives the data and helps us to understand. The formula for this is y is equal to mx plus b. So here the next graph here I have described and shown the weather delays. What are the weather delays? During the heavy rain season, during the snow seasons, these are the factors influencing the delay. And the next thing here, the most important thing I should say, the aircraft being used for previous flights and same aircraft going to be used for the next flights. This is the biggest reason the aircrafts are using in the carrier delays. And here, the most reliable reason is some of the rate here is it is 96%. It is nearest to 1. So this is the most reliable data. And here, I would say that the number of flights delayed due to the previous flight using the same aircraft being delayed. This is the most reliable data. And the next here, this particular graph, the total minutes of delay due to the national aviation, it is 81%. Now the main factors are the carrier delays, the companies, the air companies which are using the same aircraft. Another thing is the air trafficking system which they are controlling. These are the main factors, and more than the weather and other things which are delaying the flights and causing a lot of huge losses to customers. We are the victims who are paying and